Tonight we are covering the Kessler Syndrome, the danger lurking in low Earth orbit.
Hello, I'm Pam Hoffman, Everyday Spacer.
I'm Jeff Miller, CME Computer and IT Solutions.
At Everyday Spacer, we show regular folks how to personally and directly participate in space exploration, science, and astronomy. We're here on Friday nights at 9 p.m. Pacific Time, 12 midnight Eastern Time, and 3 p.m. on Saturday in Queensland, Australia. We're broadcasting live from Thousand Oaks, California. Thank you so much for being here.
Yeah, hi, Cliff.
Hey, Cliff. And Scott. Yep. Welcome.
Okay, so cybersecurity news.
You want to show it?
Yeah, go ahead and show it.
There it is.
Not much happening like right now, but just the FBI sent out a report talking about the risk of end of support edge devices. Now, edge devices aren't computer devices that hang out in dark alleys with dark cloaks and saying, I'm Batman.
Okay.
Edge devices are anything that sits on the outside edge of your network, like a firewall, your router, or your modem, your ISP's modem, whatever is the interface between the rest of the internet and your location. A lot of businesses have routers on their outer edge. And this is talking about having out of support devices, because it means that problems are no longer fixed on them. And having an out of support firewall is almost worse than having no firewall at all.
Oh, it's exploitable, I suppose.
It's exploitable and findable. A lot of these announce what they are. So people can, there are botnets that go around pinging every IP address that they can find and see what response they get back. Well, if they get back a response that looks like an old firewall or an old router, it goes on a list and they sell that list to, okay, who has exploits for this router? Who has exploits for that firewall? And they just sell it off.
Yikes.
Yeah. So that is the danger of having an out of support edge device. And that's all. There's nothing else to show there.
Oh, okay.
It's just, they talk about it a little bit more, but and that's for the show. But yeah, they don't really do much, more. It's just an awareness thing. Just look at your router, look at your firewall, if you have one, and look to see if there are any updates for it. For one thing, update it, because that'll close some holes.
Yeah, I just did my phone.
Yeah, but like a lot of people have their own routers. Your ISP should be updating your modem, but if you have a separate router, then update that. Make sure that there are, you've got updates for it. That's all.
Okay, you should do this part. I'll do the.
Okay. Hang on a moment. We've got lots of.
Well, I wanted to get this done.
Oh, okay.
Do that.
So we'll be back.
No.
Tonight's crunchy topic is the Kessler Syndrome.
Oh God.
Oh.
Right there. I've even highlighted it for you.
Yeah, but that means ignore it.
Help me, please.
Okay. This month on the 25th, so February 25th, 2026. I'm doing good. And I'm presenting today, so this will be a fun time for
Just
everyone.
Beginning.
So it will be our next cybersecurity Zoom at noon Pacific time. So.
Did you want to talk about this thing here?
Oh, yeah. Email me and I'll put you on the list. Okay. We're going to have a good time tonight.
No.
So,
yes.
Let's get to comments.
Let's do that, please.
So,
hey, Roger, welcome.
Roger's here.
Janie, yay. It was supposed to be Roger. Yeah, we know it's Roger.
Yep.
And there's Dawn. Hi, Dawn. Yep. Welcome.
Hi, Dawn.
Glad you're here.
And Janie, enjoying the opening ceremony of the Winter Olympics. Yeah.
Okay. All right. Any more?
No, I've
Not
done
yet.
this. I've done enough damage for now.
Yes. Tonight we have a crunchy topic. It is the Kessler Syndrome. We'll be back in 8.3 seconds. There's a link to that book in the description. And if you would like a signed copy, go here. Send me an email. We'll figure it out. We'll work on the details, however it's going to be. I'll get you a signed copy. All right, so by audience request, we will delve into the Kessler Syndrome, a critical tipping point where space debris triggers a runaway cascade of satellite collisions in low Earth orbit, otherwise known as LEO, rendering access to space impractical, if not impossible. What happens if a major collision creates thousands of new fragments? How could this impact spaceflight, weather satellites, GPS, astronomy, and future human missions? We'll explain how debris is tracked, why some orbits are at higher risk, and explore emerging space cleanup and debris mitigation technologies that could help preserve access to space for generations to come. What did you learn about the Kessler Syndrome this week, Jeff?
Well, here, let's go to
your setup.
Yeah.
Okay, there's your page.
Ever present wiki.
Right.
And we'll talk a lot about it. But this is a good representation. It's not to scale, but a good representation of everything in orbit that we're tracking.
Okay. So like they're kind of placements.
Right. And
is that the equator, that big ring of?
Yeah, this is actually geostationary right here. This big ring.
Maybe we should have done the Olympics. I didn't even know what was going on.
Yeah.
Carry on.
This is everything that's thrown out into elliptical orbits. And you see the really bright around the Earth? That's Leo.
Okay. And of course, it's bigger the farther you go out. So.
Right. Yeah. And quite frankly, there's more space the farther you go out, too. Now, the problem here, and I'm just bringing this image here right now, is space debris hits something, makes more debris, hits more things. That's the... Now, the Kessler Syndrome really, is... basically, they're talking about things that are like a kilogram or more. You know, that's what...
Kilogram or more, okay.
Yeah, because smaller stuff might mess up something, but it's probably not going to break it into pieces that then fly off. You know, think a bullet. It might hit a satellite and go through it,
okay,
and be significantly slowed if it makes it through the other side, and will probably be a bad day for that satellite. But it won't then make lots of pieces of satellite that then go and hit other things.
Could it remain in the satellite? Get embedded?
Could, yeah.
Okay.
Yeah.
Kind of figured.
So smaller stuff is, can be damaging to stuff that's there, but it's self-solving.
Oh, hey, Naomi's here.
Hi, Naomi.
Welcome.
But so I'm gonna say that we don't really care about smaller stuff, at least as far as the Kessler Syndrome goes. It is bad news for satellites because, they have pictures of divots in the windshield of the space shuttle. Yeah. That sort of thing. And that's, that could be, if that would have been a little bit bigger.
Space shuttle, not space station?
Yeah.
Okay.
And here's the other part of it, is that most of the stuff that's in equatorial orbits are going roughly the same speed as the other things in the equatorial orbits.
So they're kind of just going along.
Yeah, or it wouldn't still be up there. Yes. Yeah, go ahead and show a clip.
We have seen this with the Chinese blew up one of their own satellites, thousands of pieces.
Yeah, and we did it a long time ago. The Indians did it, and then the Chinese did it. And then, not more than 5 years ago, the Russians did it. The Russians.
So are these on purpose, by accident?
Yeah,
both?
no, these are testing orbital weapons.
Okay.
So these are on purpose.
Okay.
The Russian, I was going to handle it a little bit later, but the Russian strike was actually the worst of all of them because
I thought this recent Chinese one was really bad.
it was bad, but it's still equatorial. So it's kind of.
Oh, so they're all kind of going.
Right. Now they're spreading
together.
out. So they have velocities in other directions, but it's still, relatively in the Russian one is in a polar orbit.
Okay.
Which means that it's coming through the equatorial orbit.
Oh. Okay.
And it's spreading out. So they say that eventually the pieces might be covering the globe. Now they'll be really spread out by that point.
Will they get smaller too? You said 1 kilogram was kind of our.
Yeah, they won't.
And above.
They won't get any smaller. But here's the good news about it. This is why Leo has, low Earth orbit has the most debris. But it also has the shortest lifespan of the debris. They're 5 to 10 years for most of the debris in Leo.
Oh, okay.
Because
or less, right?
Yeah.
Some of the stuff comes down pretty
right.
quick.
Well, here's the thing. If you get an explosion or an impact, the debris goes in all directions. In Leo, the stuff that's going down will hit the atmosphere and go away. The stuff that's going up will probably be in an eccentric orbit that will probably hit the atmosphere on the near side and go away. So anything that hits the atmosphere is a big sponge for this stuff. So figure that anything that hits the atmosphere is kind of, it hit the event horizon of orbit.
Okay.
So it's not, stuff generally doesn't leave the atmosphere when it hits, especially the really small stuff. So you're really only concerned with like the hemisphere that goes out to the sides and up. And then the up stuff kind of is temporarily a problem. But the stuff going to the sides is what we're really concerned about.
Cliff says a fleck of paint nearly went through the windscreen of the space shuttle.
Yeah, that was the divot. Yeah, if it was bigger.
Is that shuttle housed somewhere?
Yeah, and of course they replaced that windshield.
Oh, they did.
Yeah. Oh, yeah.
Why not leave it? That's kind of an interesting.
Oh, yeah.
Perfect.
Right, but that speck of paint won't cause more debris. That's the point. Is that it doesn't mean that it's not dangerous. It's just that it won't cause the cascade.
Okay.
And the Kessler Syndrome started, NORAD was tracking debris from, tracking satellites and debris from blown up
Yeah.
Because the old Delta second stages would still have fuel in them, but still be up there once they unloaded their payload. Go ahead.
Why don't you finish?
Okay. Once they got rid of their payload, they'd stay up there. Now,
was the fuel to put them in a parking orbit of some sort?
Well, no, the fuel is just not needed. The fuel was there for contingency. Let's say they needed to change their orbit. So they always shipped them with extra fuel.
I know there's an issue with the fuel going into the nozzle, down into the engines.
Well, and that's just it. Eventually the fuel leaks and mixes and explodes.
Oh.
And so a lot of those
sound good.
A lot of those old Delta second stages basically blew up. And there's still a few of them up there that are basically ticking
time bombs. Okay.
Once they noticed that trend, they actually made rules and then basically had them, once they dumped their payload, they would burn until the fuel was gone. So that even though it was a big chunk of metal up there, it wasn't going to explode, or unless something hit it.
And those are pretty big. Yeah. Ready for this one?
Yeah.
All right. Clip goes 17,000 kilometers per hour. We'll go through anything.
Yeah. Yeah. And like I said, it's a bad day, but it won't make big particles. It'll make a hole. So that's why, and remember 17,000 kilometers per hour relative to what you're hitting. That's the big thing here.
Yeah, if they're going.
Yeah. Things that are generally going all in the same direction in orbit, unless it's a polar orbit, which is why the Russian thing was so bad for everyone. But if it's in an equatorial orbit, everything's mostly going in the same direction. And, you know, if something hits or something explodes, the smaller pieces will be going faster because that's just the way physics works.
Okay.
The bigger pieces will be going slower. You know, so that's why, you know, the small pieces are a problem, but they're not a Kessler problem. They're not something that will cause a cascade.
Okay.
And that's what we're talking about here. We're talking about things getting so bad with things hitting other things, making smaller pieces, and just, you know, flooding the orbit with stuff that basically locks us out of space. That's the whole, you know, thing behind it. And they did studies on that. And even Kessler, the guy who described the whole process, he didn't name it though. Goddard's the one who gave, in 1978, referred to it as the Kessler Syndrome to a reporter. And that's how it became a popular name.
Interesting. But they do show the name Donald J. Kessler.
Yeah. Well, and because he then, once that happened, got hired by NASA because he was doing the study of space debris. And the fact that it might hit other space debris and cause a cascade.
So this wasn't just a random Big Bang type of comment.
No.
Okay.
But, you know, so he had been, because he had been taking the listings that NORAD made and was calculating their orbits, and, you know, he was doing a lot of that work. And so once his name got out there, NASA then hired him to be the head of space debris.
Might as well. He's already gone.
Yeah.
Already working on it.
Right. And he was a name that, you know, that NASA could say, see, we're doing something about it.
We got a couple of these. You ready for
Go
that?
ahead with the class.
Yeah, running through a hail of bullets.
Yeah.
Yeah.
But remember, space is big. Space is big. So it's more like someone in the same city is firing a gun. That's what it is now. Could it get worse than that? Yes. You know, could you be in a bad neighborhood and thus be more likely to hit by that bullet? Yes. But in general, because they're talking that there is a strike per year. So your chances of being hit, you know, go now, if you stay in Leo, like, you know, you're a satellite, then you have more chances of being hit. But if you're passing through Leo, the chances are fairly small.
Okay, ready?
Yeah, go ahead.
So Roger says, that's why polar orbit derelicts are the worst. Two polars could theoretically hit each other at 2 times the orbital speeds.
Yeah. Now, the good news, yeah, because if it goes down, it's coming up on the other side. So all you'd have to do is have 2 that were out of sync with that and hit. Now, most of them are still all going in the same direction, but they rotate around the Earth. So you could have 2 hit. And yes, then that would be bad, and that would spread it all over the...
So the Russians actually launched them also south? Because that goes over a lot of turf from Baikonur.
I think so.
Wow.
But even if they launched them north, on the other side, they're going south.
Yeah.
You know,
true.
So it doesn't really matter that much.
So we got another one here. You ready?
Yeah.
Is there anything that creates drag for debris besides the atmosphere, like the Earth's magnetic field or light photons from the sun? Oh, I love that question.
Okay.
Very good.
Yeah.
Scott.
The atmosphere is the biggest one. Magnetic field.
I thought there was something to do with the sun too.
Yeah, there is.
Okay.
The magnetic field doesn't do much because most of the stuff up there is non-ferrous. It's aluminum, titanium, you know, stuff like that.
Plastic wouldn't care.
And most of the stuff up there isn't really plastic.
Oh, it's not.
The windshields are, and there's a lot of plastic in things nowadays, but all of the structure is generally titanium or aluminum.
Okay.
Just because it's stronger, you know, stronger for the weight, and weight is the killer.
Yeah, I remember the Delta.
Yeah.
Were aluminum.
Yeah. So
they had some fascinating ways to
So unfortunately,
work those.
yes, if we were launching steel or iron up there, the magnetic
Russians
field would take care of it. Yeah.
The Russians might
Yeah.
actually be.
The Earth's magnetic field would take care of it pretty fast.
Yeah, the Russians build things like tanks. The Russians would not like to accidentally drop something on the USA.
Yeah. But okay, so light photons from the sun, maybe, but of bigger significance is actually the solar wind, not the light.
Solar wind, that's, yeah.
For two reasons. One, anything heading toward the sun hit by the solar wind,
Wait, the Earth?
any orbital debris heading
okay.
toward the sun hit by the solar wind will be slowed down.
Okay.
And thus dropping into a lower orbit.
Okay.
And if it's done enough, it will auger in. Stuff heading away from the sun will get sped up. But here's the thing, is that in general, just because of the way it works, things will be slowed down more than they're sped up. And even if they're sped up, that just means a higher orbit, so it gets them out of Leo. But the other thing that...
And remember, there's an expanding space. There's more space as you go up and out.
Yeah. Yeah, cubed root. Another thing that the sun does, and again, it's the solar wind, not necessarily the photons, is that when there's huge solar events, it heats up the outer atmosphere and expands it. So it grabs more stuff higher. In fact, that's one of the dangers to low stuff like Starlink satellites. That if there's a huge solar event, it could whack a satellite or two, but if it expands the atmosphere enough, it'll cause enough drag that they have to then thrust to stay up, and that shortens their lifespan.
I got a couple of cliffs relating to the Russians would not like to accidentally drop something on the USA going north. North.
Yeah.
And Roger says the Russians did accidentally drop a nuclear powered satellite on Canada.
Yep.
Had not heard that. That sounds pretty severe.
Yeah. A lot of people like to launch stuff south because there's more ocean than land.
Depends on where you are.
In the south. Well, just in general, there's more ocean in the south.
That's true.
So there's less likelihood of hitting something. That's why we like to do that's why the Cape is so popular for that sort of thing, because it's going over the Atlantic.
Cape doesn't do polar stuff, though.
No.
Vandenberg does.
Yeah. And Vandenberg does polar stuff, which puts it
Pacific.
over a whole bunch of, puts it over a whole bunch of land before it gets to the Atlantic. Because I think it goes...
If you watch the depictions of the orbits they do, it's...
Yeah.
And it's right on the coast.
Yeah.
We've been there. We've seen that.
Right, yeah. So polars, I think they try to keep it over the water from us. The Russians probably launch. Of course, they don't have a good...
They don't have ocean anywhere.
Yeah, not near their launcher.
And the thing about Canada...
I guess the Russians don't care about China.
I thought they were buddies right now.
Yeah.
Not very friendly buddies, but... In Canada, there's not that many people, especially far north.
Yeah, well, that's why it wasn't that big of a problem.
Keep of them, 40 of them last year because of the expanded atmosphere and solar storms.
Yeah. So that's one of the reasons why Leo is less of a problem. Now, the next biggest problem is geostationary. Now it's way far out there.
Okay.
Things are actually fairly far apart out there, because when we say that we're running out of room in geostationary, and we are actually running out of room in geostationary, it's not because things are elbow to elbow. It's because the radio frequencies that they use step on their neighbors if they're near the same frequency. So they have things divided out by frequency. Like this section gets this frequency, it has to be so far away before you can have anything else that uses that frequency. So that's
I know on
why
land it's like 60 miles.
Right. And it's bigger there. out there. I think, but
Hmm.
there's a lot of space out there, so there's a lot of room. So it's not as big of a problem, but the stuff out there is more expensive, and we've got more stuff there. So
they're bigger satellites out there.
they're
too.
bigger satellites, yeah. So if something hits,
This little stuff is kind of recent. The stuff that
right, yeah,
like Starlink,
yeah, and the CubeSats, which,
CubeSats.
but so that's the next area of debris. That's the next biggest area of debris.
Geo.
Yeah, geostationary.
Okay.
Now
but those still are going to be like over the planet in a spot.
Right. They're not moving much, but if something explodes up there, then it could cause a cascade for its neighbors, to its neighbors, to its neighbors.
We got a comment from Cliff.
Yeah.
Cliff says the sats were just launched and the drag was not expected. It was a huge CME, which is coronal mass ejection.
Yep. Yeah.
Yeah.
Yeah, I remember them losing a bunch of them.
Yeah.
That way.
That were just launched.
Right. Yeah. So geostationary. Oh, what does Dan say?
Could an orbital ring eventually be constructed at geosynchronous orbit?
Yes.
Mm.
This would count as a megastructure. We don't have enough. We wouldn't be able to launch enough stuff to actually make that ring right now. It would just be too expensive to launch it. Now, from a lunar launch, yes, we might be able to launch enough stuff to make a ring.
Yeah, go get it out from there instead of here.
Yeah.
Big old gravity well here.
Yeah.
Once you're out of it, go do something somewhere else.
Yeah. Now, the mid-orbit, MEO, they call it. And
MEO?
Yeah, it's not a term that's used much because, go ahead and show it again because I want to show this picture again. See, there's a bunch of stuff. There's a bunch of scattered stuff between. Yeah. And that, no one really uses that much. There is some stuff up there.
Looks like quite a bit from that picture.
Right, but and there's like some communication stuff that doesn't have to be over one spot all the time. There's some polar orbit stuff in here, which is why this field is so big. But there's not a lot of stuff here, not compared to like this, which looks like a solid line simply because of almost like a solid line because of all this stuff. And this, which looks like just a big glowing mass. Yeah. So given how big space is, this stuff isn't really that much of an issue.
You would need to have the planet for a sphere or ring.
Yep. Yeah. Not quite, because you probably wouldn't build it very dense, but still it'd be big. It'd be a lot of stuff. And even then, a good solar wind event could possibly make it wobble. And if it wobbles, it starts becoming unstable. It could possibly, if you don't make it dense enough, strong enough, it could jiggle itself apart. So yeah, a ring is, I think, going to be a science fiction trope for a good while, because I don't see a need for it to be worth the risk.
Or it could be modular, like, well, Isaac Arthur does some good stuff on that. So.
Yeah, like
it's kind of like what we've got now going now. They'd just be like, more like habitats maybe, or something other than just communication satellites.
Right. Yeah. So yeah, I don't know that that'll happen much. There's a lot more here. Kessler Syndrome. Let's see. Space.com talks about it. They have a good. I like that image because
very fancy. Yeah,
very fancy image, and they say pretty much about the same amount of stuff. They do mention the movie Gravity, which was basically all of that havoc was caused by some space debris. Again, not Kessler Syndrome, but it was space debris. So,
I'm trying to remember Gravity.
Basically, they were up there. They got hit by some debris, and
okay. Well, it would be something else to mess with astronomy.
Yeah.
Yeah. Oh, I think I missed one. I'm so sorry. We've got one from Roger. A geosynchronous planetary ring could be a prequel to the Parnell-Nivens ring world. It is theoretically possible but definitely science fiction for a long time.
Yeah. Because I just don't see a use case for it. I don't see it being worth the effort to make. But who knows? In the future, maybe I'll be proved wrong.
And maybe at some point the modular things will be like, oh, hey, let's like hook up, connect.
Yeah, I mean,
for reasons.
Or maybe we make a giant super collider out there in geostationary orbit.
That'd be cool.
Just to break things and see what happens. You know, but you know, just another image, another computer generated image of the Kessler Syndrome, probably a little bit more realistic than that totally top down one, because this is like shows how kind of things expand out into a band.
Right,
here.
not just a little.
Right.
Okay.
Right. Yeah. So this is a little bit more realistic. This is NASA Space News. Again, oh, why the sudden alarm? Because people are talking about it. I mean, nothing is, you know, nothing has really changed. Well, the Russians did blow something up on purpose.
They've sent out I don't think it's quite 7,000 Starlinks yet.
You're right. Yeah.
But I guess there's replacements, so they are coming down as well.
And here's the thing of, let's see, what can be done to prevent disaster? Active space debris removal. You know, clear space is actually gonna, in 2026, you know, they're looking to launch to actually deorbit a big piece of junk up there.
Okay.
Now, I don't see that as a big long-term thing. Now, for grabbing stuff that's in polar orbit that's not going to hit atmosphere anytime soon, might be a good idea, because polar orbit is the nastiest. But if you think about it, you have to launch so much stuff up there just to get something down. I don't see that as the cure being better than the illness. Now, improved satellite design and traffic management. Now, satellite design, they're making things to deorbit. The Starlinks and most stuff in LEO has enough fuel not only to station keep, but then to deorbit toward the end of its life. Stuff is meant to deorbit. Now, is it great that we're putting all of this, you know, burnout stuff in the atmosphere? No. It's better than leaving it up there, though. You know, we're trading one problem for another, but it's a lesser problem, I think.
Okay.
Space traffic management, we're looking a lot. Starlinks actually do a lot of maneuvering to avoid debris paths. Not saying that they're dodging a specific piece of debris, but just there's an area where there's known debris, so they'll make sure that they don't cross that area. So that's another thing that we're doing with extra fuel up there. Things have extra fuel to not become part of the problem. International collaboration. A lot of the space agencies are talking to each other about space debris and stuff like that and sharing it.
Because a few bits came down here, as in Australia, I take it, and were caught on camera just recently. Yeah, I think it's already up there. I mean, wouldn't it be cool to reclaim it? There's a great movie called Space Sweepers.
Yep.
It's very fun.
Yeah.
Korean, I think.
Yeah. And that's along the lines of all of the movies where people are dodging asteroids in the asteroid belt. You know, I don't think that the space debris is close enough together to make something like that viable. I mean, we'd have to have an awful lot of stuff up there to make that viable.
Sure, it looks like a lot, but again, space is big.
Yeah, space is big. And most of the stuff out there are little flecks of paint. Now, can you sweep those up? Yes, you can, throw up, vehicles with aerogel and stuff like that. But you have to launch that. You have to send it up on something. And that something, the second stage, unless you deorbit it, is going to stay up there. So you're putting stuff up there to pull stuff out. And it's just like, it's just not Now, grabbing big stuff, that's in polar orbit, yeah, that's a good plan. But to get all of the smaller stuff, I don't see it as being really viable when you figure that you get one strike per year on average.
Okay.
So you put something up there that collects stuff, and it's getting, maybe you make it really big and it gets 3 or 4 strikes per year. How much is it actually cleaning up versus how much you spent to put it up there? See, that's just, now are there areas that are denser and stuff? Yes. Might it make sense to put something up to collect, like a big aerogel wedge to collect stuff in a specific spots? Maybe. But that's that's going to be a case by case, not a general solution.
Okay.
Yeah, go ahead.
So Dan says, polluter pays. When do the lawyers get involved? I expect they're already involved.
When something damages something else, that's when they get involved.
And Scott says, could high-strength lasers fired from Earth vaporize debris?
There is actually a plan for that.
Wow.
Now, they're not trying to actually vaporize the debris.
Oh, okay.
What they're trying to do is vaporize a bit of the debris and use that as reaction mass to make their orbit non-circular, to basically make it eccentric enough that it goes out, comes back in, and augers into the atmosphere. So that's what they're talking.
Cool.
They are looking at doing that, and they are talking Earth-based lasers for that. Now, again, they're not strong enough to actually vaporize the debris, except maybe flecks of paint, but I don't know how they track those. But like something that's like a kilogram, they could possibly hit it in one spot enough to basically make a jet. Now, if that 1 kilogram piece is spinning, you'd be warming it as it spins. I don't know if they can hit it hard enough, fast enough to actually vaporize anything off of it, which was the thing that made the our SDI, Star Wars program not really viable, because if you spin the rocket, spin the missile, it just makes a warm ring around the missile. It doesn't actually burn through it. But we knew that. We also knew the Russians would actually spend the money to spin their missiles, and we made them spend that money. So, okay, Cliff, yeah.
Yeah, and if it breaks, it's stuck up there too. He means the collecting. Yeah,
exactly. And even if it doesn't break, you then have to have enough fuel to deorbit it. So yeah, it's not. There aren't good solutions for it except time. The good news is, let's see, I don't have it to show, but I did look up some stuff here. I did time. Okay, lifespan of debris in crowding. In Leo, crowding is very high. Debris lifetime is years to decades, and collision risk, they say, is extremely high. In geostationary, crowding is moderate. Debris lifetime is centuries plus. The main thing that gets stuff out of geo is perturbations with the gravity of the sun and the moon. And that takes a very long time to have a meaningful impact.
Because those are really high.
Right, yeah. The moon actually has more impact on it than it does on lower stuff, because it's closer to the moon and less effect from Earth. Now, MEO, which is the medium orbit, crowding is lower because there's not as much stuff in there, and debris lifetime is decades to a century. And
that's a fascinating chart. I wish you had set that up for.
Yeah, here, let's move this over where we can see it over there.
Cool.
Oops, hang on. Okay. There we go. Go ahead and share.
Is that it?
Yeah.
Okay, hang on. So,
yeah,
right in the middle of the screen there is this chart.
Yep, hang on.
Quick worst orbits cheat sheet.
I just I chatted I GPT'd a bunch of stuff just to have it, you know,
Oh,
you
that's
know,
Chat GPT. I see.
yeah. You see, I'm not showing this because not all of it's real, but this is basically useful.
And like they always say at the bottom that it could be wrong.
Yeah.
So
Yeah.
do double check.
Yeah. So, and even Kessler said that the Kessler Syndrome isn't something that'll happen in the next few years. He said it's decades away unless something major happens.
Okay.
You know, so.
But some of these things will say, is it 2 days from now? That's more clickbaity, I think.
Yeah. Yeah. No, it's you know, he was talking headlines back then, but now it's clickbait. And it's nothing, you know, it's not. In fact, I found a number of sites that show it as oh no, the sky is falling. And it's
actually
concerning.
If it's falling, it's a little better than if it's sticking up or sticking
yeah.
around up there.
But I meant, you know,
that's funny.
Everyone's going to die because of this. It was the kind of blog post that I saw. And so I didn't bother showing those.
I see.
You know, it's just it's just not that big of an issue. It is something to luck out for, but it's manageable. I mean, Starlinks dodge stuff all the time. Now, 2,400 maneuvers to dodge stuff last year. But of course, there's a lot of Starlinks.
Yeah.
And if one of one batch is dodging they're setting the whole batch to dodge because they're generally done in strings. Now the strings expand over time, you know, but still, if any of that string is going to be going through a danger zone, a lot of it will be. You know, so but it is 2,400 maneuvers last year for Starlink.
Wow.
So, you know, it's not free to mitigate it, but it is something that we have a solution for right now, as long as it doesn't get worse.
Okay.
Because as long as it doesn't get worse, it'll get better. You know, because stuff will keep dropping down. And new stuff is designed to deorbit. Stuff that goes into geo is designed to basically, with its last bits of fuel, decircularize its orbit or move it into a place where the sun and the moon will have a bigger effect on it and bump it out that way.
Okay, I gotta come from Cliff. The first incident involving people will change things.
Yes.
Well, and I mean, we've got rules for all kinds of things. Like in this country, we drive on the right side of the road. Maybe we'll have some kind of something determining.
Yeah. Well,
something up there in space. I don't know.
The good thing about equatorial orbits is that generally, unless something blew up, everything's moving in roughly the same direction. Because you get a boost from the Earth's rotation when you're launching in that direction. You know,
Roger did a whole thing on that.
Yeah. So it doesn't make sense to launch in the other direction.
True.
Unless you want to start running into things. But so most of what you'll be running into in low Earth orbit is stuff either entering the orbit or leaving it, you know, going up or down at whatever. I mean, it doesn't have to be like straight down. It could be at a very shallow angle heading down. And that would make it, you know, a problem for a while. But so stuff going through the orbit and stuff that blew up and is spreading out like this. And even then, the stuff that's heading in the same direction, you know, even then, it's only the speed of the explosion added to it, because otherwise you're going roughly the same speed. So if something breaks up, you know, it's not like you're going to be hitting it head on like this. It's going to be catching up to you, or you'll be running into it. And so the closing velocity won't be as big. Now, polar orbit, things get really dicey, because that is a large, as Roger pointed out, that can be potentially a large velocity change difference. Yeah. And polar orbit intercepting an equatorial orbit, again, you're hitting it from the side at whatever speed the polar orbit is.
Got it.
And so that's where things get dicey.
Mm.
That's why we're more concerned about polar orbits.
Okay.
And luckily, geostationary, I don't know if anything is geostationary. Oh, hi. Hi, Hein.
Whoops. I went to click and it went away. Hi, Jerry is here. Welcome. We're so glad you are. And then we got Daniel says, if GPS went away, you can still do terrestrial navigation with optical landmark recognition and radio beacons, etc.
Yeah. So, and I don't think it'll get bad enough that GPS goes away. I mean, I don't think so. It would take deliberate action to do that.
Okay.
You know, I don't think that it'll happen by accident. And I don't think that it'll get worse now unless someone makes it worse, because we've got enough stuff in place right now to keep it from getting worse. And barring getting worse, it'll just get better as stuff gets, deorbited, auto deorbited essentially. So if we hadn't woken up and seen the danger, we could have possibly have screwed ourselves up.
Okay.
But even if we have the Kessler Syndrome going on, it doesn't mean we can't launch stuff. We just can't park it in Leo. Because even still, space is big. The chances of getting hit by something going through Leo up is very, very, very small. Now, will it be so small that you'd be willing to put people through it? I don't know. But, it will be relatively small. The era of the ISS or ISS-like vehicles could be over if we get a Kessler Syndrome.
I see.
You wouldn't want to be there for it.
Yeah, certainly not in equatorial type of but over the pole,
well, here's the thing. You're going through because he has a plan to orbit essentially the pole, not orbit the Earth. So
an orbit is hanging out right there.
Well, and here's the nice thing about that is that it avoids most of the polar orbit stuff. Because polar orbits don't actually usually go over the poles. They go, if you look at the old, if you look at the charts, polar orbits look more like a sine wave going around the Earth. Now it is doing an actual circle. It's just that as the Earth turns, it's not going right over the pole. It's going kind of at a diagonal. And as the Earth turns, it looks like a sine wave over the Earth.
Yeah, even the space station kind of looks like a sine wave as it orbits.
Yeah, but things like JP's plan, putting stuff, orbiting the pole, actually would be not bad. Also, his stuff is still somewhat in the atmosphere, so anything that would hit it.
140,000 feet?
Miles.
Is it miles?
Yeah. But it's still,
it was like the airlines.
He's floating it at the edge of the atmosphere. So, basically underneath it is atmosphere. Above it is very, very thin atmosphere. So.
No, it's 140,000 feet. Like airlines. 30,000 feet is highest an airline can go.
Yeah.
So this is another 100 some.
Right, yeah. So it's still up there, very thin atmosphere.
Yeah.
Yes. But still, stuff in that realm is more likely to get burned up in the atmosphere. So it is still less risky.
So I got some comments. You ready? So 42-year-old the space shuttle. You read it.
42nd year old of the Space Shuttle Challenger crew mission.
It's been 42 years. Wow.
Yeah, 42 years. Yeah.
That was in January, though, wasn't it?
Yeah.
Thank you. Let's see. Some say robots give a bigger return on investment for space development anyway. Like robots to Mars kind of thing.
Well, yeah, I don't think I'd send people to Mars, but robots are very bad at figuring things out. Just saying.
They're close enough they can talk to the people.
Right. I don't think I'd want a totally robotic moon base. For instance, I'd want boots on the ground so that you don't have something that, oops, we didn't account for that. The entire base is now dead. Because something hit a power line or something, and nothing has the power to go fix it. Whereas a human, let's strap on some oxygen, let's go fix it. Humans don't need to be a specialized tool. They have, multi-purpose tools.
9,000.
Yep.
Just don't lie to it.
Yeah. Don't make it lie. That's what happened.
Don't make it lie. Okay.
Yeah.
Do you have more?
No.
Okay.
Like I said, I used, I'm showing a ChatGPT screen right there, but I used that just as part of my research. It has some pretty pictures.
You want me to show that?
Sure. Let's just show the pretty pictures. Okay. Worst area is low Earth orbit, and they give the 160 to 2,000 kilometers and just a diagram of low Earth orbit. And basically at 2,000 kilometers, you're hitting the radiation belt, so you don't really want to hang out there.
No.
And what's in Leo? They have a bunch of stuff showing why is this Leo risky, high relative speeds, but yeah. Second worst is geostationary, and again there. It tried to grab a copyrighted image, huh? This is why I don't generally show the ChatGPT stuff. The satellites do not naturally fall back to Earth, is why it's dangerous in different ways. Debris can remain for hundreds of thousands of years. It's a limited ring. They call it the Clark belt. So space is precious. Uses of it. Third worst, medium Earth orbit. Again, pretty pictures. We do have, that's where GPS lives, essentially. Galileo is a European thing. Baidu is China. GLONASS is Russia. But so that's what's in the medium orbit. So yes, medium orbit is the least risk, and that's where our GPS is. So you'd have to target them, quite frankly.
There you go. Cliff says, I first saw that. I think he means space. Yeah. What's the name of that movie with HAL 9000?
Oh, yeah. Space 2001 Space Odyssey.
Yes. In 1968, I was 19. I actually saw it when I was 16 because it came back to the theater. So that was 17 plus a bunch.
Yeah.
So somewhere late 70s.
Yep.
So interesting.
So, how likely, again, this is chat. How close are we to Kessler Syndrome? We're not in Kessler Syndrome because it's just not enough to make a cascade event right now. But collisions are already happening. But 2009, 2021, the Russians did it on purpose. They point out here that it was not Kessler Syndrome. It was just, it just happened. But it did create debris cascades. It just wasn't self-perpetuating. Kessler Syndrome is self-generating debris. Once it starts, it doesn't stop.
Okay.
So
cascades for good.
Right. Yeah.
Okay.
Now, would the debris get smaller and smaller? Yes. As collisions happen, will some of it get either kicked out or dumped into our atmosphere? Mm-hmm. Yes. So again, it will solve itself, but maybe not in our lifetime if something happens like that. So satellite number exploding, mega constellations. So are we on the brink? We're not in safe, clean orbit, but we never were. In the 60s and 70s, they were getting micrometeorite impacts. Manageable, but risky. Yes, that's where we are. If you go up there with blinders on, you might have problems. Localized Kessler zones, possibly in some altitudes. I don't think that there are any Kessler zones. There are just some areas where stuff has hit and made more debris.
Okay.
Global runaway Kessler Syndrome, no. Even the AI says that no. So that's about it.
Okay. Interesting. It's a fact that we've been definitely using AI, but we sat down and talked about it the other day. As long as we're presenting like this, it will be us talking to you,
right?
not
yeah,
an
like
AI
I said,
generated
I did it.
image of us.
I did it for research purposes. It just had a good chart that I showed. I actually wasn't going to show any of it, but when you said that would be a good chart to show, okay.
Well, it looked interesting to me, so I thought it was okay. Anyway, so and we'll tell you too, like he said, that was from ChatGPT. So,
yeah.
All right.
Yeah. I mean, it's a good tool as long as you use it as research, not, don't be the grade school kid copying directly out of the encyclopedia. Use it as a tool so that you can then do your own thinking around it.
Yeah. Yes. Don't let the car navigation run you into a lake.
Yes, and it has happened.
I've heard of that. Certain meteor showers would not be a good time for launch too.
Yep, exactly. Yeah, you see, so it's never clean up there. Even before we had even before we had our own space debris, there was always stuff up there. You just have to, you have to look both ways before you cross the street. I mean, it's always been. Now it's just more traffic.
Okay. All right.
Yeah.
Good?
Yep.
All right. So this year we are building new products and services for you. What would you like to see in the Everyday Spacer store? In fact, I'm looking at AI tools now. Janie and I have already talked about one. I have made some progress on that, Janie, just so you know. And it's going to be an interesting tool. It's so fascinating how the GPT kind of thing will say, "Oh, this is a great start in for something else." I know John Limbacher has talked about it a lot. John Limbacher created the quantum AI suite that I've talked about in the past. So, yeah, there's some possibilities there. If that sounds interesting to you, let me know. All right, so I'm going to go ahead with some stellar events this week. We're talking about February 6th through February 13th. It's the beginning of the month. And remember, skymaps.com gives you a free resource for anywhere on Earth. It's a 2-page PDF that you can print out. I'm going to go over that. Oops, I got to do this.
Before you do that,
yeah,
I just had another thought on Cliff's comment here about certain meteor showers would not be a good time to launch to, but it doesn't mean you're doomed if you launch during it, because a lot of meteor showers are number of sightings per minute or per hour,
and the size is
per
like
hour. So you've
dust.
got minutes between them, and they're dust sized, and that's across the whole sky. So even during a heavy meteor shower, you're not very likely to hit something on your way up while you're launching. Still, it'd be dumb to do. It's meteor showers are predictable, so don't do that. But it's still not likely to hit you.
He's got another comment there too.
Yeah. They can see anything larger than a golf ball, and there are 350,000 objects. Yeah.
I think there's more than that.
They are tracking more than that, about double that. Yeah, but big and density matters more. The amount of mass matters more. Actually, a lightweight golf ball size thing is almost the best case scenario, because it wouldn't hit as hard as, it wouldn't have the penetrating force that something smaller would have, smaller in the same mass.
Be a risk factor.
Yep, exactly. And they worry about that. They worry about the risk factors, and they plan for them.
About Kessler.
Yeah.
Okay.
That's fine. And it's something that could have happened, Dan. It's just that we figured it out and made it so that we dodge the stuff, we track it, we dodge it, and we try to make sure that there isn't more. You know, that's the only time that I think that we would have a Kessler effect right now is if someone took a war out into space and essentially vandalized space, because that's essentially what the Russians did. They just vandalized space by doing a polar orbit, explosion. But yeah, so it'd be a terrorist act. I would consider something like that a terrorist act.
Yeah. Okay, good.
Yep.
Because I'm going to go over here and show you this. It's been a while, or I'm not even sure if I've shown you skymaps.com. It's very simple. Skymaps.com, real easy. And you want to look for this link right underneath. So this is the main page, skymaps.com. Then you go to download the latest issue, which takes you to the page itself. It's a 2-page PDF. And this is sort of a mock-up of it, but I would get it from the download because, as you can see, it's a little fuzzy.
And that mock-up is 2019.
Oh, yeah.
So don't use that one.
It must just stay there.
Yep.
All right. So you've got several areas, and they still have January, in fact. So February Northern Edition, that's for the Northern Hemisphere. February 2026 Equatorial Edition. And February 2026 Southern Edition. So anywhere in the world, you can pick up a skymaps.com download. I'm going to go ahead and actually do this one. So let's see, what do we get when we do that? Yep, there it is. So February 2026, you've got all kinds of great stuff in here. I just love this. I usually print them out on both sides, one side of each. Okay, and let's see, I'm going to go and talk about... what's the next thing here? Oh, come back to us for a minute. Because the Farmer's Almanac for February has the basic synopsis for it. I'm going to just go ahead and read that. Saturn appears as early as 6 p.m. as the only bright star in the southwest. It is lower each evening, making this its final full month of visibility. On the 8th, Mercury begins an evening star apparition, best seen at 6 p.m. Though low in the sky, it conspicuously floats above Venus at mid-month. On the 18th, Mercury is next to the thin crescent moon, with Saturn to their upper left. At 6 p.m. on the 20th, a rare vertical line appears in the west, including from the bottom, Venus, Mercury, Saturn, and the moon. By the 28th, Mercury has dimmed and dropped lower in the west, while dazzling Venus now appears 7 degrees high at 6 p.m. as it begins its long 2026 apparition as an evening star. Notice they have 6 p.m. in there a lot. Mm-hmm. That was kind of interesting. Did we get a comment?
Because I think that's when things start to get dark. But
got it.
Yeah. So Cliff says Dave got a C-Star S50 scope and has gone nuts with it. He
nice.
Loves it. Yeah.
That is cool. Okay.
So apparently Dave can buy stuff and not make it rain.
Oh, that's just me. Come on. All right. So come. Let's see. I want to let you know that you can also get stuff from. Go ahead and share the. Yeah, you can get stuff online at almanac.com. And I mean, this is a really terrific resource. The best skywatching events of 2026 is here. It's the 37th day of all these cool things. They're based on the United States, so that's why this is Abraham Lincoln's birthday. I think they do have some things from other places, but not as prevalent as the United States. And they have, they have these moon phase calendars. And what you want to do, I'm going to put in, let's see, 91360, our zip code, and it's got already for February 2026. The what's the moon's phase today? Let's go ahead and hit go there. And it's going to give us a whole chart as well as this information here.
Oh, right. Cliff has a comment that Dave's 700 KOA, yeah.
Right. And let's see, what's today? Here's a waning, give us 74.9%, 19 days. Okay, and just so you know, Everyday Spacer is now sponsored by CME Computer and IT Solutions. We are very grateful for that. I think the next thing I wanted to talk about was let's do that in a second. I'll set it up though. There, the February 7th spike is 1.8 degrees north of the moon. February 9th is the last quarter moon. Oh, that's why I had the Almanac thing up there. And the next Globe at Night project begins. Go ahead and bring it back to us. Yeah, to this. And here's the Globe at Night campaigns, February 9th through the 18th. We've actually got options for both Northern Hemisphere and Southern Hemisphere. And I know this is true because the words up here, I just happen to be below them.
Looks like Orion goes both ways.
Yeah, right. Orion is visible from both Northern Hemisphere and the Southern Hemisphere. The dates are 9th to the 18th. And if you want an alternative, it's Perseus in the north and Canis Major in the south. There's lots of great information in here about how to do it, the charts, observing. Let's see, is this magnitude charts? Anyway, they have lots and lots of good information in here if you want to browse around some more. And you can come back to us. I think that's all I have.
And Dan has Falcon 9 Vandenberg launch window tomorrow at 9:21 a.m.
Oh, thank you very much for that. All right, so February 10th, the moon is at apogee. In fact, it's 251,392 miles from Earth. And Antares is 1.7 degrees north of the moon. February 12th, the moon runs low. And Friday, February the 13th, is our Friday night show. I think I'm going to be doing, like I decided right before the episode, another audience request, unless we get a guest. We got a couple people we're talking to right now, so we'll see what happens. Find us Fridays at 9 p.m. Pacific time on the Everyday Spacer Facebook page and the Everyday Spacer YouTube channel. What inspires you the most for the coming week? Yeah, we got a comment.
Yeah, Cliff says I was with him, Dave, when he got the scope and used it on Norfolk Island and got fantastic results.
Oh, that's good. Wonderful.
I'm glad you got to look through it too then.
Yes. Is that typically nicer area, the Norfolk Island?
Well, it's dark sky because it's away from everything.
I get that,
else.
But is it cloudy?
Yeah.
That's the trouble where Cliff is.
Yeah.
So we'll be interested to.
Yeah. Okay, so if you or someone you know has done something interesting involving space exploration, science, or astronomy, we'd love to share our live. Join us again next Friday, February 13th, for Anthropofuturist. There's a channel on YouTube, and there are other groups, Anthropofuturist groups. Basically,
I don't even know what this is, so
yeah,
it's gonna be interesting.
Someone suggested it, and Pam decided she'll run with it and figure it out between now and next Friday.
I found something on YouTube that looked kind of like this, but
yeah,
it's not the same. So
okay.
Oh, in the middle of Pacific Ocean.
Yeah, that's where Norfolk Island is. Yeah.
So unless in the middle.
Yeah.
Are you sure?
So unless
that sounds more like Hawaii.
Got a bunch of cruise ships that decide to just swarm the thing with all of their lights on, you're going pretty good there.
Yeah, interesting. Okay, so anything else for you?
Nope. I think I've caused enough trouble.
Yes, you have. We will continue to watch for your comments as well. I'm good. And we had Cliff and Daniel. Whoops. Oh hello. Ollie Space. Do we know Ollie Space? Do we know you? Well, we had Ollie Space here, Cliff and Daniel, and
Hein Cherry.
And
Naomi was here.
Yep, and
Scott,
Dawn, and Scott, and Jamie.
Yep.
Did we get Roger?
Roger was here. Yep.
Awesome.
Whenever we call out the names like this, I always want to get out the magic mirror.
Is that from Mr. Rogers?
No, it's from Romper Room.
Oh.
You have to be much older than that to know what
you said Naomi, right?
Yes.
Okay, good. All right, Jeannie. I don't think we missed anybody.
No, I don't think so.
Awesome. We really appreciate you being here week after week. It's so amazing, actually. Thank you very, very much.
Cliff says, Mutiny on the Bounty relatives lived there. That's Norfolk Island.
Oh. Okay. Interesting. All right. Anything else, Cliff?
That's actually kind of neat.
Yeah. We will still continue to look for your comments. And yeah, at this point, good night.
Good night.
Have a great week, folks. We'll see you next Friday. It's Friday the 13th as well.
Oh, good. My lucky day.
Yep. Bye.
Bye.